Thank you for joining us today as we launch the Shrubwise Data Challenge. This initiative exemplifies the Wildfire Commons mission to bridge the gap between cutting-edge computational methods and real-world wildland fire management needs. And by focusing on shrub fuel characterization, which is the theme of the challenge, we are tackling a fundamental challenge that has long limited the accuracy of wildfire behavior models. So this is a very important problem that's solvable through, we hope, machine learning, AI, data, and computing and use of it. And I'm excited to see what our community of talented people can develop here. And of course, it's really hard to come to a point that we can do a challenge on something like this. It's a very challenging problem. And it takes many people's efforts and hard work to get to this point. So I want to thank to the team. Some of them you'll hear from today. Some of the collaborators are on the call. I really, really appreciate everyone's enthusiasm and hard work and collaboration on this. And I also want to say thank you to Claire and Melissa, who led this team from the beginning to this point. With that, I'm going to pass it on to Letitia and some of our leads for the challenge. Thank you so much.
Hello. Okay. Thank you, Ilkay, for leading us off. And yeah, so this challenge is about characterizing the shrubs. So basically, why do we care about this? Low-lying woody vegetation, i.e. shrubs, are an essential driver of fire behavior, especially in this Southern California region, where we have shrub-dominated landscapes. And we really know that the spatial arrangement of shrubs do play a critical role in how fire spreads across the landscape. But a lot of traditional fuel models have focused on forested ecosystems and not really characterized the influence of shrubs on fires. So in our group, we have been working a lot on next generation fire models. So this is like three-dimensional fire models that can more readily take into account these shrubs. However, we don't really know exactly where they are or how tall they are. So there's a real need for these high resolution 3D vegetation inputs of shrubs. Next slide, please. So the goal of this challenge is just to map the shrub distributions at a high spatial resolution and to build this machine learning pipeline that accurately characterizes shrub ecosystems. And what we mean by the machine learning pipeline is that we'll first have training labels. So we'll define the target outputs for the model. And in this case, it will be shrub cover and shrub height. And then these will be the training labels that we use to train the model. So we'll prepare and curate the training data. We'll have multiple data sources that will be available for students to use, and they can do a variety of data cleaning processes to help refine their data. And then it will be for model development. So we'll train and refine the machine learning or AI model using this data set that they've created. And then we can iterate on these features, the different architectures, what parameters might be involved in the model to improve the performance. And finally, we'll apply the final model to generate predictions at over a landscape. So produce this in order to produce a high resolution shrub map. Okay, and now next we'll hear from some of the people that we work closely with. So first we'll hear from Chris Anthony, who is a fellow at the Societal Computing and Innovation Lab at UC San Diego. And he was a former chief deputy director of CAL FIRE. And he's going to help explain why shrubs are important to identify for practitioners.
Thank you so much, Letitia. So when I first learned about this data challenge, I realized that it was going to be complex but critically important. And the reason that I say that is because the steps that we take to either reintroduce fire or other types of fuels reduction treatments in our shrub ecosystems is critically important to not only the ecological health of these landscapes and environments, much of what you see in Southern California and along the coastal areas of California, but also to our communities as well. And when it comes to our shrublands in particular, it's not really a matter of, do they need fire? It's just really a matter of the frequency of that fire in those shrubland ecosystems. So the work that I think this is going to really help inform is, some of those outcomes and helping us think about, you know, uh, what kinds of data sets are missing in terms of our ability to more accurately model prescribed fire in these ecosystems. As many of you know, when it comes to the fast fires that we're seeing in Southern California, many of those are running through shrubland ecosystems. And so understanding how we can more appropriately manage those ecosystems, the use of fire and other tools is going to be really important, because it goes both ways, not only in terms of the fires that start in the landscapes and move into the communities, but also those fires that can start in a community and move into those landscapes as well. I'd also like to add that, it's not, the shrub structure really matters, not just the presence of the shrubs themselves. And so the height, the density, the vertical continuity, those all influence how a fire is going to behave in those ecosystems. And shrubs they can be generalized, they can be misclassified, and they can create blind spots, both in our operational planning and our prescribed fire planning assessments that we do to better understand um, the right kind and type of fire that needs to be reintroduced into some of these ecosystems, if that's the right management tool in the right place. And we also know that these systems are really dynamic and they change quickly. Even those that may have burned, 10 years ago, those shrubland communities do change very, very quickly. So, hopefully this challenge really helps close that gap between the science and the practitioner, and helps the practitioner um, really be able to think and have tools available to them that they didn't have before within this ecosystem. And that translation between what's happening here with this Shrubwise data challenge and the outputs that will actually be very relevant to the practitioners in the field that are struggling with these issues on, I would say, nearly a daily basis. And I think the science that comes out of this is going to be really helpful to informing those outcomes and will lead us into a much better place in terms of our overall management of our shrubland ecosystems throughout California. So thank you so much, Letitia.
Thanks, Chris. And now we'll hear from one of our modelers. So Adam actually is a research scientist at Los Alamos National Laboratory. And yeah, so he will let us know a little bit about why shrubs are important to identify for the model on the modeling side.
That I think shrubs are important from the modeling perspective. And this was stated before, but probably needs to be stated again. Shrubs are important and need to be represented in all models. And so not even in the 3D fully computational, fully physics models that we've been using lately, but all models have an aspect, or a lot of models have an aspect of shrubs that are baked into them if they're empirical or even 2D. They're a significant portion of the overall fuel load, and in many ecosystems, shrubs are the dominant species, and so, or type of plant, and that's especially true in the chaparral. Shrubs are close to where it all happens. They interact with the surface fuels. They help build the surface fuel. They dominate the condition and that surface fuel condition dominates fire behavior a lot of times. And then in a 3D perspective, if we think about this from the models that we're using here, I should probably go in slideshow mode. I'm sorry. We like to use these fully physics based models that you represent 3D forest structure. And so we have two different models that we use. We use one that's fire tech, the other one that's quick fire. Fire tech solves the Navier-Stokes equation. Really what that means is it's a computational fluid dynamics model, and that is coupled to the atmosphere, and it's coupled to the wind component of the atmosphere. And so anything that sticks up from the ground is going to affect fire behavior in these types of models, and shrubs do that. The way we represent shrubs in these models is through voxelization. It's the same way we represent trees. And you can think of a shrub as a smaller tree. Sometimes they'll small enough to take up one grid cell, but often they'll take up multiple grid cells. This 3D fuel structure, again, is where sort of the fire meets the landscape along the surface, and therefore it has likely an outsized effect to fire behavior. And it's going to both affect the winds that are moving through that fire, as well as the combustible material near the ground. That's why you have that classic ladder fuel attribute to shrubs. And so it has all kinds of effects to the fire behavior. And I'm just going to take you through several examples of how that can matter. And again, just here, our models hypothesize that fuel arrangement matters for predicting fire behavior and fire effects, and that a fuel arrangement on the surface is largely dictated by fuel clusters that come from shrub and grass arrangements in the landscape. So those examples of how vegetation structure and vegetation fuel heterogeneity affect fire behavior, here I'm going to just show you three examples real quick. One example was published 5 years ago, and what we did here is we just arranged the vegetation structure throughout the landscape. We tried to keep we kept the fuel load the same. This is all just vegetation structure movements across the landscape. And with these different clearing and fuel arrangements, you get different fire behavior. In fact, those results are shown here, where we have, if we look at those fuel structures, we looked at an even, maybe something that looks like a plantation, a heterogeneous forest, and one with clearings, and you get different fire spread rates depending on your conditions, and the winds for those types of fuel arrangements on the landscape. In this particular case, we see that forests or shrublands with larger clearings tend to spread faster, and the most heterogeneous landscape, and this is because this was a wind-dominated type simulation, you saw the slowest fire spread rate. A second example of how we can detect that vegetation structure matters in fire behavior is if we model and represent the actual landscape in our condition. So this is a canopy height model that we've created in California, and we demonstrated in California. And what we compare here are just how different mappings of the exact tree and shrub location across the landscape affect fire consumption or the fire area, as well as spread rate. And so what we did here is we had a LiDAR representation of the landscape, a very precise representation that included trees and shrubs, and then our canopy height model, and then again conserving the fuel load across the landscape. We mixed everything up and tried an imprecise representation of fuel across the landscape while maintaining the fuel density, while maintaining the overall number of trees in the landscape. So really, this is just an arrangement condition. And we see differences in the wind profiles. That's what this first plot shows right here. So the dotted line is the non-truth, so to speak. And then fuel consumption, our actual forest representation shows a higher fuel consumption or air mass of fuel over the fire area, and the spread rate increases with the actual distribution of vegetation across the landscape. And lastly, we've seen that clearing the forest out, clearing out the shrubs, we represent different fire effects. So here we're simulating scorch height of a forest. And for this experiment, we've controlled the intensity of the fire along the surface. So this is imposed on the model. And just from the presence or absence of vegetation on the surface and the density of the canopy, we predict different scorch height in the forest. So those are the three examples of how knowing where shrubs are can affect fire behavior modeling and why we would want to keep tabs on that. And with that, I will pass it back, stop sharing somewhere, and pass it back to everybody else.
Thanks, Adam. Yeah, that just highlights the importance of why shrubs are important for the fire models. They seem to really, the structure that you input seems to really affect the fire models. So now we'll just hand it over to Pedro, who will discuss about how to sign up for the data challenge.
All right. Thank you very much, Leticia. And thanks to Chris and Adam again for giving us this great context that shows us why this data challenge is relevant. And now that we know the importance of the work that we are aiming to do, let's now review the logistics and the next steps on this data challenge. So first, the enrollment. People are encouraged to enroll to the data challenge before Friday, February 20 to receive priority support. And to do this, first, all the team members must register with Wildfire Commons. Otherwise, if you try to add a member to the data challenge that is not previously registered in Wildfire Commons, you will get an error. Also, the registration has to be completed using an academic email. That means an email that is associated with a university domain or with org ID. If you fail to meet these requirements, you will need additional support to access the computing resources. So you are highly, highly encouraged to register with either the university email or org ID. Anyone can participate. This is an open invitation for people in academia, for students, for people in industry, public agencies to participate in this challenge. And very importantly, no participant can be part of more than one team. But so Friday, February 20 is the deadline for priority registration, but the very last day to register, the registration will stay open until April 3rd. We can go to the next slide. So these are the phases that you're going to go through in this data challenge. A first phase will consist in onboarding. In the first phase, we want you to get yourself familiar with our platform, Fireforge, which is the main platform where all the resources associated to this challenge are going to be available. We want you to get familiar with our Jupyter Hub service, and most importantly, how to work collaboratively using our platform. On a second phase, you will be introduced to the core data sets and the foundational concepts that will help you understand better what are the challenge goals. On a third phase, participants will be introduced to relevant data products that they will explore, learn how to access, manipulate, and identify how to incorporate into their workflows. And in a final phase, participants are expected to build and document an end-to-end machine learning and AI pipeline that will give us a data product that will better characterize shrubs. And what are the provided data sets? The following data sets are going to be available through Fireforge. And all of this information might sound intimidated right now, but we are going to provide training resources in the form of modules that will help participants understand better how these data sources can be used. And also, any participant is encouraged to use any additional open source in the data set in their pipeline. The schedule for these modules that will be supporting participants and they will give them better context on the challenge goals and the data sets to be used. It's the following. Today, during the release of this challenge, the onboarding workspace is already available. And as I mentioned, this one is to get yourself familiar with the main platform where you're going to be developing your work. On February 19, we will release the materials associated with Spring 1. On March 5th, the materials associated with Spring 2. And on March 19, materials associated with both Spring 3 and Spring 4. With the fourth sprint being the sprint where you're going to develop the final product in which we expect you to deliver this pipeline characterizing shrubs. And I just saw in the chat that there's a question about the registration link. We will go over that in a minute. The final deliverables and judging. So deadlines. For the work associated for sprint 1 and 3, which are tasks that we are very interested for you to complete because this will give you the foundations that you will need for the fourth sprint. The deadline to submit this work will be Sunday, April 5th by 10 p.m. Pacific time. And the details on how to do this submission will be explained at the release of the sprint number 3. And then for the final deliverables that are going to be judged by our panel of judges, those have to be delivered by April 19 by 10 p.m. also Pacific time. And the details on how to submit this work will also be provided when Sprint 4 is published. Also, if you need any additional support with any of the sprints or any questions related to the challenge, we will gonna be hosting office hours between February 20 and April 17 every Friday, except for March 27. These are going to be hosted between 1:30 and 3 p.m. Pacific time. And you can schedule office hours on the link that is going to be provided in these slides and also in the data challenge page inside Fireforge, which I'm going to cover in a couple of minutes. So a quick recap, this is the timeline of the challenge. Today we are launching officially the challenge and we are starting the onboarding phase. You will have until February 19 for priority registration. And on this day, we're going to release the Sprint 1. March 5th, we'll release the Sprint 2. March 19, we are going to release the Sprints 3 and 4. By April 5th, you have to deliver the work associated with the Sprints 1 to 3. By April 19, you will need to submit your final work. And on May 1st, we anticipate to announce the winners. So the onboarding. So the following slides are going to cover the next steps that you will follow to get yourself familiar with the platform, start working on the challenge, registering with your team, working on the onboarding workspace, and everything related to the overall environment that you will be using. Also, there is a link on these slides to the Wildfire Commons documentation, which has additional information that it can support yourself in getting familiar with the platform. So, as I mentioned, the next slides will cover this onboarding. So the very first step is registering the platform. You will go to the Wildfire Science and Technology Commons site and click on the Login Register button at the top right. Then you will select Sign in with CI Logon. On the CI Logon page that you see on the right, you will search for your university, or if you don't have a university email, you will search for OrgID and you will log in OrgID using the credentials that you use to register at OrgID. Or if you select a university, you will just log in as you typically do with your university access system. And once you register in Wildfire Commons this way, you will complete your user profile so the Wildfire community can see your expertise and can look at your profile. And after completing this step, you will go to fireforce.wildfirecommons.org, which is the platform where we are going to host the resources associated to the challenge. You will agree to the terms of use and enter the site. And once inside the site, you will locate the menu on your left panel where you will click Data Challenge followed by Explore and locate the Shrubwise Data Challenge. Click on View More and you will be able to review all the information associated to the challenge, which is the same that we are providing in these slides. You go to the next one. After reviewing the materials of the data challenge, you will click on Join Challenge and you will be able to set a team. You will assign a team name and you will also enter the emails of your team members. As I mentioned previously, if any of your team members is not registered yet in the platform, you will get an error. This is okay. You can still create the team and eventually add the team members. but just notice of that. And also notice that the team name is going to be exposed to the data challenge judges. You can choose whatever name you want, but this name is going to be exposed to the judges, not to other teams, but to the judges. And go to the next slide. Okay, so once you join the challenge, you will get access to the modules associated to the challenge. At the time that if you join the challenge between now and February 19, there's only going to be one module now inside of the challenge, and the next modules will be released on the dates that I previously mentioned. So after locating the onboarding module, you will click on view and you will read all the instructions carefully because that is going to be your guidance on how to execute these models and how to open the Jupyter Hub service and start working collaboratively inside that environment. So you will click on view more, and on the following slides, we will give you a quick overview on how the Jupyter Hub will be launched. So essentially what you're going to do is you're going to select the workspace on the drop-down menu inside the Jupyter Hub service that you will deploy once you open the workspace. Then you will reserve the resources as instructed in the instructions of the module. Once you do this reservation, you will start your server. This process typically takes a couple of minutes. And once it finishes loading, you will see a page like this with an extension of the left, which is the connection between the Jupyter Hub service and the resources in Fireforge. You will notice that you will have two folders. One of them will be associated with your personal storage and the other one with your team storage. And these will have the same name that you assign to the team when you register for the challenge. And there are also good practices regarding shared storage that we encourage you to review. And once you review that, you will get back to the extension, select the workspace that you want to start working on. You will clone the repositories associated to this workspace because this will have the notebooks that you will be instructed to complete. Some workspaces might have requirements files attached to them. So if this is the case, you will be able to install the requirements using the extension. Please note that these requirements are not persistent. Every time that you stop a server and come back, you need to reinstall these requirements. Then you will also identify the data sets that are part of the model and add them to your environment. And in some cases, and this is important for the final sprint, you will be asked to add additional data sets to your workspace. So if this is the case, you will get back to the workspace in Fireforge, click on the Edit Datasets button, select the data set that you want to add, and then refresh your workspace so these datasets can be bring into the Jupyter Hub, and this also applies to GitHub repositories. So after going to these steps of familiarizing yourself on how to interact with the workspace and the Jupyter Hub, you will be able to open the notebook that is associated to our onboarding workspace, and you will follow the instructions over there. So these steps are going to be documented in these slides. And also, if you need any additional support to understand how to work with workspaces, you can always email us at info@wildfirecommons.org so we can provide additional support. So with that said, I will pass it back to Claire.
Excellent. Thank you so much, Pedro. And thank you to everybody that's been able to share more about shrubs, why they're very important to our modeling and practitioner work, and why we care about them for this challenge. And I'm excited to share, a debrief with you all of what we're looking to take as our next steps. We have registration, as mentioned in detail by Pedro. We'll make these slides available along with the recording so you can take your time going through these steps. We encourage you to find some team members. Go find some friends, colleagues, advisors that you want to be a part of this effort and recruit them to join you. We'll be able to have you start working on that onboarding module right away. It's available to you. It'll allow you to have more familiarity with how the system works within FireForge, get experience with Jupyter Hub, especially if you're a pro, you're going to love it. And if you're new to Jupyter Hubs, it'll be a space that you can really adopt a new skill set. And then once we have February come our way, we're going to be launching those modules, which I would encourage you to just take some time, set aside some time each week to look at, review with your team, making sure that you're able to come to a cohesive agreement of how you want to start positioning your pipeline. And if there are questions that arise, feel free to reach out to us. We're always happy to answer any of those questions and even review some of your work in the prep modules during those office hours. And finally, the most important date of all, April 19th. We'd love to see your work. Please submit it, share it with us, because it's actually going to be utilized by our colleagues that are working on these modules. It's going to be utilized by some practitioners and researchers that are actually in the field right now, looking at fuels, looking at shrubs, and our good work here today is going to help them move forward and take some really good next steps. So with that, I'm going to close out with a thank you, and we have some time for questions. So I do want to open up any questions that were brought up. I know one was mentioned of how to get registered. I hope that that was addressed through the slides presented already. But if there are any other questions, feel free to pop them in chat. Maybe one question I can ask Pedro for his opinion here. What is the best advice that you would give a new team that's maybe looking at a data challenge for the first time? What's maybe some good advice to kind of ground themselves or feel confident about the work they're about to do?
So there will be two. Number one will be to complete the onboarding, because that's typically the biggest bottleneck to get themselves familiar with the platform and how to work with a Jupyter Hub. And the second one is if they want to get a sense or an idea on how this challenge is going to be structured and the kind of work that they will be asked to do. Inside FireForge, we have an example data challenge of an onboarding from a data challenge that we ran last year. And so the structure and the design of those models, it's going to be very, very similar to the one that we aim to cover, and also the tasks to the ones that we're going to be releasing in the following weeks.
Excellent. I do want to give it one more minute to see if folks have questions here. And of course, if there are any questions that you want to ask us offline, we're happy to take those again at that info@wildfirecommons.org. Hopefully folks are already emailing their friends and booking some times at some coffee houses to sit together and start working through this challenge. And I just want to reiterate that this work is actually going to go directly to folks that are working on these models and working in the field so we can identify our shrubs more effectively. I'm not seeing any additional questions in the chat. Maybe I'll call on Letitia for one final word of wisdom before we close out today. Letitia, any guidance to our folks that are going to join this challenge? Any thoughts that you want to give them? Oh, sorry, you're muted.
I was muted. I guess just have some fun and don't hesitate to reach out to have if you have any questions about the data sets or about how to use them. We will definitely try to help you to the best of our ability.
Excellent. Thank you very much. And Scott, great question. I'm glad you're able to uh, share that thought with us. We can definitely set up a designated space where folks can link up, be able to have some discussion. We have a good connection with one of our communities that helps lead a social space. So we'll connect you in with there and see if you can find some good colleagues to work on this challenge with. So does that sound fair? I'll do a follow-up and stay tuned as well in our newsletter, especially when you're signing up for your profile. That's where you can be briefed on all the good things coming out of the Wildfire Commons and our partners and communities. So we'll be able to share more information too about, some of the great prizes that will be coming out of this challenge. So, it's always great to have this work be done because it betters our community, but also it's nice to have a little incentive. So with that, we will close out today. Thank you again to our speakers. This is wonderful, and we look forward to seeing everybody's work through the data challenge.